Hey, my name is Ohad Vilk. I'm a postdoc at the Hebrew University, where I also did my PhD. Um, During my PhD, I worked a lot with animal movement. We looked at displacement of animals, and we asked all kinds of questions about properties, statistical properties of their displacements, and actually matching models of anomalous diffusion and other memory-based models to the data we worked on. And during my work as a PhD student, I noticed that we are focusing a lot about focusing on the mean square displacement, the second moment of distribution. We are repeatedly focusing on that, and we might be missing other features of the distribution in many of the systems that we have looked on. So in my poster, actually, I will tell you about strong anomalous diffusion, which actually is a way to identify these limitations of the limitations of the mean square displacement when working with data. And we are familiar with the mean square displacement, and we know that it is maybe a default go-to method when working with diffusion models. And here I'm giving several examples, and what's shared, these are different examples from very different scales, the time scales and length scales. But what's shared is that all of these take some kind of anomalous diffusion model, which is more complex than regular diffusion, but still focuses much on the second displacement of the distribution, on the mean square displacement, sometimes also on time averages, but on the second moment. In order to understand the limitation, one has to look not at the second moment, but at the general moment. So here I define the general moment, moment Q. And for a simple model, for instance, random tumble model, we can plot the different moments, and we can measure the scaling, the slope here for each one of the moments. Here, these are the values of the slopes. And what we see is what is called monoscaling. Essentially, we have some kind of self-similar form for the distribution, and this actually is realized in the fact that there is one scaling function. In these kinds of processes, the MSD actually characterizes the distribution in full. But this is not a general case, right? So if we take, for instance, a Levy walk, if you want more details, come see my poster, but if we take a Levy walk, we actually see that this is not the case. We have some kind of biscaling in the distribution. Here, this is an example from data of Barnell that I will discuss in a minute. And we see that we have different scaling for the bulk of the distribution and another scaling for the tail of the distribution, which is again realized by the fact that we have some biscaling here. So looking at higher moments or looking at different moments can give us insight into actually the distribution of displacement from the data. For this work, we looked only at the barn owls, but we actually have looked also at other species. But these are 60 barn owls. We looked at adult barn owls and fledgling barn owls, and I will show not here only the adults. If you want more information, come to my poster. And we actually saw very interesting dynamics that indeed resemble or give strong anomalous diffusion. We also found another feature of the data that there is some kind of break, some kind of biscaling in the moments themselves. And again, if you want to give more details, please come see my poster. Thank you very much.